So the question becomes, how do we get a thing that's charged negatively to become neutral, and how do we get a thing charged positively to become neutral? Well, here we go. So our title here is Neutralization. So if I have a negative object, boom, 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 so an object with excess negative charge, an object with excess positive charge, well, what needs to happen? Well, this object would need to get rid of all the excess negative charge. And this thing would need to gain back as many electrons as it's lost. So let's say this thing has an excess of 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons. So this thing has a charge, and we said Q is a symbol for charge a while back, a charge of negative 9e, meaning it was missing 9, or excuse me, it has 9 excess electrons. 1, 2, 3, 4, 5, 6, 7, 8. Well, let's throw a ninth one on there, right? And this has a charge of positive 9e. This thing is missing 9 electrons. This has 9 extra. This is missing 9. Oh, well, you'd say to yourself, okay, fair enough. If I just touch these two things together, the 9 extra electrons from here would come over here, and they both end up neutral. And that's how I neutralize. But if you think about that, that doesn't make any sense, right? That's like saying every time you want to get an object back to neutral, you have to find something that has exactly the right amount of excess charge of the opposite flavor, right? Like if you have something that's negatively charged, you have to find something that has exactly that many missing electrons on another object, or an object that's positive, you have to find something that has exactly that many missing extra electrons. That's not the way things work, because it would be it's not just impractical, it'd be almost impossible. So how do we do this? Well, let's talk about the Earth. The Earth is massive, right? If you think about the number of electrons on just your average object, say the number of electrons and protons on this. So this is a thing of aluminum, right? And it's about, 200 grams worth of aluminum. This object has a billion times a billion times a billion electrons. But it's neutral, so it has a billion times a billion times a billion protons, exactly equal, right? But the Earth is so much more massive than this, right? Like, if I were to pull one electron off the Earth wouldn't even notice it because it's so much larger than other things. Or if I were to put an extra electron on the Earth, it wouldn't mean anything. It's like putting one drop of food coloring into the ocean. It's so small with respect to the overall size of the ocean that it doesn't have any effect. We're going to use that in order to discuss something called grounding. You've probably heard that before, electrical grounding, right? I know you have heard of that. If you've ever seen a 3-prong plug, the cylindrical one, not the 2 flat ones, is sometimes called the ground or the ground wire. We're going to see what that means when we get into our electricity unit, but it's going to be the same idea. Grounding is connecting an object to the Earth. And it doesn't actually have to be the Earth. It could just be to a much larger object. So connecting an object to the Earth, a much larger object, using a conductive pathway. Okay? So, the Earth, in this case, or the ground, the way that we say it, the ground functions as an infinite sink or well of electrons. Meaning, I could put a billion extra electrons on the Earth and it wouldn't even matter. I could pull a billion extra electrons off the Earth and it wouldn't matter, right? Because of the size of it compared to other things. So, the symbol for grounding is the following. if I draw an inverted triangle with 3 lines, right? So the symbol for grounding is this. So I connect my negative object to the earth. So remember what we said before, that that excess electrons, or electrons, always want to move from a place at a high electron concentration to low electron concentration. This negatively charged object has a high electron concentration. The electrons would flow out of this object into the earth until it is neutral. Similarly, if I were to ground this positively charged object, electrons would flow from the region of higher electron concentration, which in this case is the earth, because this thing is missing electrons, up onto here until it is neutral. So therefore, if I ground a neutral object, or rather, excuse me, a charged object, I neutralize it. Okay? But I don't want to say that grounding is neutralization. They are two separate things. We're going to use grounding for some other purposes later, but if I do ground a charged object, it will become uncharged. So if I were to have this object and it is charged, if I just touch it anywhere, it becomes neutral, right? This object is a conductor, so if I touch it in any one spot, the whole thing is grounded because the charge is free to flow all throughout this. But if you notice, all throughout this, I've been holding our other objects. This is an insulator, so when I do this, I'm not charging the entire thing. I've only charged this end of it. I can hold this, right? Because I'm only now grounding this part of it. So for an insulator to ground it, you have to touch every part of it. So if I want to neutralize this, I would have to do that, right? And so that process then would ground the whole thing and therefore neutralize the whole thing. So we saw in the video, the last video, that the pith ball didn't remain charged all that long. And the reason is because it is April, and April is a very humid month. And so if you think about the air, dry air is an insulator, right? That we don't tend to get a lot of charge movement through dry air. But you'll recall me also saying that water is a conductor. So humid air is just air with a lot of water dissolved into it. And so if I have that pith ball, and the pith ball is surrounded by humid air, what ends up actually happening is that there's a conductive pathway from the earth to the pith ball through the humid air, which causes it to ground constantly. So that's why it's been very difficult to keep things charged here at home during the month of April, because the humid air is constantly grounding things, which is why I have to keep on charging things up. If this was a colder or drier month, I'd be able to keep things charged longer. But you probably already know that because we're talking about the flow of charge. Oftentimes, well, not oftentimes, one flow of charge here would be lightning. And so we're going to talk a little bit about lightning and have a video or two for you to see. Well, what is lightning? Lightning is just it's a grounding process, right? Is that there's excess charge that's flowing through what normally would be an insulating material in order to get back to equilibrium. And you'll notice, well, when do we get lightning more often? We get lightning more often during storms, when there's a lot of moisture in the atmosphere. Now, I'll tell you, most clouds end up being positive here. And so when you have lightning, what's actually happening is electrons are going through the humid air that is a pathway for them, and then jumps up to the cloud. But we'll look at lightning as a phenomenon, but it's just a grounding process. In the same way that when you zap someone, when you rub your feet on the carpet, you end up building up an excess charge. Then when you bring your finger near someone, that's a grounding process, that you're becoming both neutral through that. So if you're negative, you're shooting electrons to them, but if you're positive, you're pulling electrons off of them. And so those little sparks are just actually little miniature lightnings. And so we'll look a little bit more about lightning. Why? Just because it's interesting.